recognizing speech on Android tonight. The talk has something for beginners and for advanced, I promise. So raise your hand if you're a newbie to Android or haven't touched it before, or have no plans to touch it, and you're just here for fun. And raise your hands if you're an intermediate Android, you've made a project or two, maybe not on Google Play, but you've done some stuff. Okay, raise your hands if you have an app that's in production.
Don't be shy.
Yes, don't be shy. I'm not shy. Raise your hand if you have an app in production. Okay, cool. So we're a nice mixed audience. Nobody's declaring they're a newbie, but I'm still going to give a bit of newbie stuff for those who didn't declare. So basically, my talk tonight is going to be about a specific project I worked on while I was in Batumi, and I'll give you more details as I go along, and we'll start with a demo, so don't worry. It'll all be easy, I hope. So let's go to the slides. Alrighty, I'll go full screen. I'm hoping you'll be able to see it, but if there's any text you can't read, just let me know. So, yeah, today I'm going to talk about recognizing speech for Kartuli. My name is Gina, and my colleague Esma is not here tonight. She's sleeping. It's now 3 in the morning in Georgia, so she's not with us, but we are broadcasting live on a Google Hangout if anyone wants to join. I think I posted it on my website. I don't remember where I posted it, but you guys are here, so you're fine. Okay, so our roadmap today, we're going to talk about things for newbie developers, intermediate developers, advanced developers, and speech techies. So one other group population who might be here tonight. Did anyone come tonight because they like recognizing speech?
Georgian.
Well, I bet there's no Georgian speakers, but if there are, raise your hands. Yeah, so anyone here speak Québécois French? Ah, another minority population. Okay, so off we go into the talk. So here's a bit of context. This is Georgia. I'm not talking about the state. So what you see in purple is Georgian. There are roughly 4 million speakers of Georgian in the world. That's the equivalent of Montreal in Sud et Nord. So if you want to think about yourselves as speakers of a language, which is Montreal French, which is a true language, and that's why Google doesn't say, Salut Google, ça va, ça marche pas, right? Google doesn't recognize that. So if this is helping you get an idea of what we're going to talk about, it's just this small problem for some small people. Not a big problem for many people. So let me give you maybe some more context. The Georgian language is called Kartuli. Okay, Kartuli. I'm not going to do any more than that tonight, but it's very different from English and French. Really different. The words are really long. Yeah, you got a good example here of these things. So it's just not a language which is built for speech recognition systems, but speech recognition systems aren't built for that. And so most systems, well, they don't exist, first of all. There are no speech recognition systems for Georgian. And even if you build one, you have a very, very low chance of success. We're expecting around 10% accuracy, which is completely unusable for most people, but we did it anyway as an exercise, my friends and I, so they could learn some Android and learn about intent in Android. So that's what I'm going to show you tonight. So we built an app. It's on Google Play. You can actually download it and play with it. We have over 150 Georgian users from Georgia who are using this. I didn't expect that. But yes, Androids are in Georgia, and they have Google Play, and they can download it, which is all a miracle, by the way, right? Like the fact that Google Play actually works in some countries and some doesn't. It actually doesn't work in all countries, and you can't actually make the apps in all countries. It's a miracle. So we have some users, and they are using the app. And I will give you now a demo of the app. So let me exit. Full screen mode. So I'm using Droid at Screen, which is a screen share for Android, which I might need to restart. I'm comfortable with the good old stuff. It might take me a second to get it into position because it's really big on that screen.
There is no way of Google translating that.
No. Well, so translation and speech recognition are two different problems. I'm going to show you the app and you'll see more, I think. When in doubt. It's the curse of setting things up 20 minutes before your screen turns off. Okay. Cool. It's even the right size. Okay, that's good. Good enough. So I can make it bigger, actually. I made it that small on purpose, so it would fit. But I can switch it now. So let me try. Okay, that'll be a lot better. Okay, so I'm going to show you our app, and I'm going to show you what we're talking about. So raise your hand here if you can say OK Google to your phone. Okay, so some people know what that is, and some don't. I guess I better demo that first. So OK Google is easy to use. What is the population of Quebec?
7 million.
It didn't catch Quebec, because I didn't say Quebec. Oh, it got it.
February 1st, 2014.
Can you guys hear that? He's not very loud. But, so it got it and said the sentence. So that's speech recognition. It recognizes what you say, and then after that, Google does a web search to find the result, and if they're lucky and they found the result and they're really happy and confident that that's the result, they'll even speak it to you. Raise your hands here if you can say OK Google to your phone. Okay. So, yeah. So let's now look at our app. So this is the welcome page for the trainer app. You can click on the red button to do some recognition. So if I click on it, you have a choice between the standard built-in recognizer by Google or our recognizer. So for English, Google's better, so I'm going to switch that one. 1, 2, 3. And then it recognized 1, 2, 3 with pretty much good confidence, and it's going to show it to me. So that's what I'm going to show you next in code. And now I'm going to show you our app, which is not as good. I'll show you in English. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice. Okay, so that's the demo, yeah? Let's go on to the code. And we'll come back for the other part of the demo if you want to later. Okay. So, the easy way to recognize speech, it's 4 lines of code. Anyone can do this, even if you've never seen Java before. So basically, you make a new intent. You say, my intention is to recognize speech. I'm going to add the extra of what language model I want to use. I want to use free text. Like, the person can say anything they want to, and I'm going to try to recognize it. And then optionally, you can add a prompt saying what you want to show to the person, right? So it could be, I'm listening, or in Kartuli, it could be Gisnet, which means I'm listening in Kartuli. And then you start your activity, and you get your results back. So this is, for beginners, newbies, easy stuff. It's calling an intent. This is highly recommended. I'll repeat. Don't make your own speech recognition engine. You don't need to. It works. It doesn't work so well for Quebecois French, but if you fake a French accent from France, Sometimes it works better. Okay. So now let's switch to the hard way. This is for intermediates. This is how you can register your app to do speech recognition. It's really easy. It's 3 steps. It's not hard. Step 1, you register for the intent for recognition of speech. Step 2, you accept extras for prompts, like you're going to show the user what they're supposed to say. For example, what is the number you want to dial? That could be the prompt. And then step 3, you return results for the scores of confidence, optionally, and the results of your recognition. So let's go into detail. This is your manifest. It's an activity here, speech recognition activity. You can say the intent that you want to run is recognize speech, so now you're registered for that. You can now accept those intents, and that's why you get that pop-up box that I showed you guys, where you can choose between the recognizers. And that's that. Next step, accept the extras from the prompt. If you're a good developer, you'll do this, because users might send this to you. And sometimes you have those 3 things, you can recognize speech. But usually you do it really badly. So to make Alexa, to make a language model, the only thing you need is a text. So if you really want to make a recognizer for Québécois swear words, you could write a text of swear words and run the pipeline, and it might give you a model of swear words in Quebec, which you could recognize. So this is all possible if we choose to make something for Montreal. It's like, yeah. So you run it, and it gives you some stuff. Same thing for a lexicon. So a lexicon is actually easy to build also from a text. It won't work for French. But if your language like Georgian, so Georgian, as you saw, is Unicode. And there's a one-to-one correspondence between the letter and the sound, which is good, which means you can write a mapper for that, and you can generate your lexicon pronunciation without a lot of work. So again, for recognition of Georgian, a text is all we need so far. And we have the acoustic model, which is another problem and I won't talk about. So what are we doing with our app? Well, I didn't show you the other half of the app, which is the trainer. So I'm going to show you the other half, if my phone is still connected. It is. OK, so there's another half of the app. It's the top button, which says train. So if you push that, this is my friend Nina giving you instructions and an example of how to do it. You can't really hear it because we're not speakers. So then you should say it. And this one I don't know it. This one is about Facebook settings. And those ones I don't remember. So after you've done your training, then you can, oh, it's in English, excellent. Normally it's in Georgian. You can add your own words and sentences to train it to your own language if you want to. So you can click continue, and then you can create new lexical items, new words, new sentences to train it to your own language. And then we use this to feed our models so that each user of our system has a model that's built for them. And so we might go from 0% accuracy to maybe 5% if we're lucky. And the more they use the app will get better and the more that it will train to their voice. We don't have many high expectations, but it was still a very fun project. And yeah, these are, so thanks to all of my friends actually in Georgia, I should name them. So there's Esma, Nina, and Camila, and Mari, who helped me a lot with learning Georgian, not to mention translations, and they learned a lot about GitHub. They're all on GitHub, I'm very proud of them. And my other friends who learned how to develop Android stuff. Yeah?
So the application creates, by the training creates a model of each person.
Yes.
It's the audio model.
Yes. Cool. So I think it's really important, right? So if you think about me as a speaker of English, my English is a little bit strange. I speak the software English, so the words that I want to recognize are actually software terms. That's not going to be part of any language model. It's default on an Android. So when I got my Android about 3 years ago, I started reading text that I wanted for recognition. And I remember distinctly some of them were things like, there were logical texts like lambda x such that x is blah. And lambda is not a normal word, and such that is not a normal sequence. So it took 5 repetitions before it learned my version of English. And that's how the built-in recognizer works. It has its own language model for you. So if you speak to your Android more often, it will understand you better. So if you give up immediately and you just say, God, that sucks, then it won't do anything. Yeah. Any other questions? Yes, you want to see it? Sure. So the NDK project I often open with Sublime because I'm too lazy to load C in my clips anymore. So the NDK source is very simple. You have 4 files that are in Java that are your bridge. If you want to see the JNI, it's even more exciting. Let's go in here. So basically, I don't know when, but a few years ago, the Sphinx, Pocket Sphinx guys switched over to using, I think it's like, automatic generated interfaces so that whatever's in the C you can call from Java, which has been pretty awesome. It really meant the app could go a lot further. There was about 3 years where the Android Pocket Sphinx didn't change. Do you want to see more in here? Do you want to see the Java side or? Okay. Sure. Yes?
the audio which is processed by the train, it's stored on the device.
Yes. So it's stored both on the device and also sent to the server. So we also have a server which is using Field City, which is my project that I do for fun. And that server lets you have, each person has their own database with their own text and audio.
What is the format?
So the audio?
Yeah.
AMR? Yeah, and then we convert it, we use FMPEG on the server. We use Node.js and FMPEG to convert the audio into RAW so that we can run it through the pipelines for things.
Space format.
Yeah. Yeah, it's pretty tricky. The format is like one of the biggest questions if you try to do this stuff for the audio import. It's like one of the hardest things to get right because otherwise you get really weird errors in really weird parts of the app. Yeah. Good question. Yes. So, and that's great. Asked if we should run this on the server instead. So why are we processing speech on the Android? And the answer is, in Georgia, there's no Wi-Fi. Or if there's Wi-Fi, it's very limited. And if there's good connection for data, it's very limited. So we don't upload when we don't have to. So we recognize offline. And now that is maybe a context where you guys might think, okay, I might want to make a recognizer so I can work offline. But the news is that you can use the built-in one offline now, too. You can download the language pack. If you go in your settings, if you actually are interested in this, you can actually download your language pack and do speech recognition offline, which is really important. So for our users, there's no option. We have to be offline, even if we're using Pocket Things. To use Pocket Things for things on the server makes really no difference in terms of accuracy, unfortunately. So we'll see what happens. We have some more accuracy. Yes, of course. I know. But what if you want to be offline? You can set comments. That's it. Si possible offline, simplement en français, tu peux télécharger de language pack. Même pour le Google, le built-in, tu peux être offline, ça c'est. Pas sûr pour passer là, honnêtement, je ne sais pas. Mais oui, c'est ça. But yeah, so that. Do you have a dictionary for the user's words? Pardon? If the user has a code. Oh, yes. So this is one of the cases where you would want to like train it with their own voice. So if you have but speech recognition isn't that fragile. It's not the code that's going to be the problem. Usually, if you're going to use a word it doesn't understand, and nothing's going to make sense after that, so it can't give you better results. It's not all, like you could have peanut butter in your mouth, and it might work. Anyone else? Yeah.
How do you try to train these guys? How many hours?
We don't know. It's 0%. It's just a research app. I'll give you an update in a year. I don't know if I have time to work on it. Yeah. We're using HTTP. The question was, how do we send the data? Yeah. 1% more. Honestly, I think the biggest thing to get more accuracy is time. So we built this project from March until May, and now the project is sleeping. And then maybe next semester they'll return to it. I don't know what will happen. But I think the biggest challenge is just having time to look at this stuff and understand what we're doing, and maybe listen to user feedback too, right? Because the users are trying to use it. Yeah. So I think the real answer should be more data. That should be the right answer, but we don't know. Could be other things. There can be. Sometimes you can do a trick and it's going to work better.
A few slides ago, you set an intent. You can see that you are going to receive the accuracy scores or the meaning scores for the feature condition.
Yes.
It's possible to enhance the score with semantic information or grammatical rule, for instance.
Absolutely. So, and the question is about this confidence score. So it's a good question. He wants to know if you can use semantic information or meaning to decide what the person might have said and choose between your results differently. And that's actually a really important part about language. When we're speaking to each other, we're in the context of this room. We all know I'm talking about Android. Yeah? So all the things that come with Android, like intent, it's higher likelihood that you would recognize that because we're in this room together. Whereas if you're on the street and talking about intent, what's your intent to do this? Like, that doesn't actually seem to be a normal word. So that's what you would do if you want to build your own custom recognizer. You can recognize the speech from Google using the built-in one and then tweak the confidence scores to what you think is the right context for that user. Of course, if you don't control both pieces, you can't tweak as much as you'd like to. But that confidence score, yes, it's a valuable measure to people who use you and use your app. Okay, I'm going to wrap up, and I think we're ready for the next talk, or maybe we could have a small break. Let's do a small break while we get set up. Feel free to mingle and mingle.